Good afternoon, students. Today I am going to start your next chapter, that is magnetic effects of current and magnetism. So your last chapter was current electricity. Remember what you learnt in current electricity? You totally learnt about effects of electric current, electric charges and electric current. So what do you mean by electric current? Electric current is it is the rate of flow of electric charges through a part of the conductor. The rate of flow of electric charges through a part of the conductor is called electric current. So imagine an electric current, some amount of electric current, maybe few amperes, 1 ampere or 5 ampere or milliamperes or microamperes, some amount of electric current is flowing through a wire, then in the surrounding region of the wire, so I mean in the upward region, downward region, or in the side regions of the wire which is carrying the electric current, there some special effects are found. Those effects makes you to believe that there is an attractive force, or there is a repulsive force. So some kind of force is present in the surrounding region of the wire carrying an electric current. So what it is said, whenever a current flows through a wire, magnetic effects are produced. So what I am going to tell is, in the surrounding region of the wire there exists a force called magnetic force and a field called magnetic field. So if see here, if a conductor, wire means conductor, if a metallic wire, if a wire or a conductor is carrying the electric current, then we can identify or we can experience a magnetic force and hence a magnetic field in the surrounding regions of the wire. So here one thing I can tell you straightly, that magnetic field or magnetic force that is directly produced by the electric current. So here electric current is charges in motion. So whenever an electric charge is moving from one point to another point, it produces, that electric current produces a kind of force and a kind of phenomena that is called magnetism, and that force is magnetic force. So here what is magnetic force? If this is your question, then magnetic force is the force of attraction or the force of repulsion that is present between two metals. So say for example, if an iron metal is placed near to a magnet, so then there will be a force of attraction. If a gold is placed, gold or silver, it is placed to the magnet, there will be a weak repulsion from the magnet. That will be known to you in the next classes. So first I want to tell you about magnetic effects of current and magnetism. So this is your next unit and it is considered as 4th unit of your syllabus, and in this unit specially you are learning about magnetism, how magnetic field is produced, what is the definition of magnetic field, what are the different formulas related to magnetic field, SI unit of magnetic field, and what do you mean by magnetic force, how magnetic force is created, and what are there are two formulas for magnetic force, and those two formulas will be known to you in this chapter. So what are the two different formulas of magnetic force, and see from the magnetic force which are the devices they are working, or what are the devices that work mainly because of magnetic field. And in this chapter you are going to learn Orsted's experiment, Biot-Savart's law, cyclotron And what are the uses of cyclotron? So this is one of the important chapter which gives you 7 marks for your final examination. And see here problem numerical section is not asked. Usually problems are not given from the chapter magnetic effects of current and magnetism. So theory complete 7 marks are given from the theory part. So this stands as one of the useful chapter for your scoring, because from this chapter problems are not given. So here see magnetism is the phenomena which makes you to feel about magnetic effects or magnetic field, right? So here see here magnetic field, first I want to tell you about magnetic field. Magnetic field means this is the space. If see here this is the conductor, this conductor is carrying the electric current. Electric current is imagine this is the conductor, and I am using copper wire here. I am using copper wire here, and that copper wire is adjusted like this. And see, this is the cell. Imagine this is the cell. So now the two conductors are made free. This is one positive conductor and here is one negative conductor. So now place some metal pieces, iron pieces, ಸಣ್ಣ ಕಬ್ಬಿಣದ ಮೊಳೆಗಳನ್ನ ಈ ಒಂದು ಇದು ಸೆಲ್ಗೆ ವೈರ್ ಸುತ್ರಿ, ಕಾಪರ್ ವೈರ್ ಸುತ್ರಿ. ಕಾಪರ್ ವೈರ್ಗೆ ಏನು ಮಾಡಿ ನೀವು ಇಲ್ಲಿ ಈ ಕಡೆ ಒಂದು ಎಂಡ್ ಇರಲಿ, ಈ ಕಡೆ ಒಂದು ಕನೆಕ್ಷನ್ಸ್ ಇರಲಿ, ವೈರ್ ಅದು ಶಾಕ್ ಏನು ಬರಲ್ಲ. ಡೋಂಟ್ ಟ್ರೈ ದಿಸ್, ಜಸ್ಟ್ ಇಮ್ಯಾಜಿನ್. ಸೊ ಇಯರ್ ಏನಾಗುತ್ತೆ, ವೆನ್ ವಿ ಪ್ಲೇಸ್ ಮೆನಿ ನಂಬರ್ ಆಫ್ ಸ್ಮಾಲ್ ಐರನ್ ಪೀಸಸ್ ನಿಯರ್ ಟು ದಿಸ್ ಸಿಸ್ಟಮ್, the two ends, positive wire, negative wire, the two wires they start attracting the iron pieces. It is just because of magnetic field and hence magnetic force which is created by the cell, because this cell is having electric current, and that electric current is created by the connection of the wire. It is supplied by the connection of the wire. So in the surrounding regions of the cell now there exists a force called magnetic force, and that magnetic force started attracting the small pieces of iron metal. So that is magnetic force. And magnetic field, see how to define the term magnetic field. Magnetic field means capital B. Magnetic field is the space around a wire or a conductor carrying the current. If this is the current, this is the space, this region, upward region, downward region or side regions, the space around a current carrying conductor where a body experiences a kind of force, that may be force of attraction or force of repulsion, that is called magnetic field. The space around a current carrying wire or a current carrying conductor where a metal experiences a force of attraction or a force of repulsion, that region is known as magnetic field. Magnetic field is usually denoted by the term capital B.